Humans, here we go, another round of videoage. Yes, I said it, it's a word, just now made up. Solving systems with elimination. Now we have two methods by which we've solved systems. We've graphed, and we have used the substitution method. The elimination method is actually a variation of the substitution method, but it's a little more straightforward if your equations are conducive to using the elimination method. Here's some steps to using elimination. Read it. Okay, let's see how that applies to a given equations. Oh, found one. Cool. Let's remember our steps. There you go. Gave you a small reminder. Oh, all right. So these equations are set up very, very nicely for us because you can see that the x's in each equation, there's two x's in the first and there's negative two x's in the second. So if you were to simply add these equations together, watch what happens. These will add to 0, these will add to 8y, and these will add to 24. So you can see that y, when solving, will be worth only 3. And like the final step says, you can take this idea and plug it back into one of the original equations, whichever one you think will be more easily workable. So I'll plug it into the first. 3 times 3 instead of y. We know what y is now. And we can simplify a bit, subtract 9 from both sides, and discover that x must have a value of 2. Huh, that's fun. The system has a solution, 1, 3. Now, why does this work? You can actually turn this into a substitution problem. Watch. So the first equation is 2x plus 3y equals 11. The second equation, negative 2x plus 5y equals 13. If you move this to the other side, you have 2x equals negative 3y plus 11. Do you see? All we've done is taken this 3y and put it on the other side. And now you have this statement, 2x equals negative 3y plus 11, and this one remains unchanged. Watch. You can show that this is what's equivalent to 2x. Well, why don't you put this wherever you see a 2x? So I'll do that. We're substituting in to the second equation, negative 3y plus 11. You still have this 5y, and you still have 13. Negative, negative. So this changes the sign to 3y, changes this sign to negative 11. You still have 5y equals 13. And if you go through the steps to solve this, you'll end up with some of the same statements from above and actually discover that y is equal to 3. So it has its roots in the idea of substitution because we saw that something is 2x and we put it in there for 2x substituting. But not to confuse you, just to show you where that came from. The process that we're learning today, the new process, is this idea of elimination. And this is how it works. If you have them set up where you can see that one of the variables will disappear if you simply add the equations, then do that. Add the equations together. Sick. Another example. Here's your system of equations. Now, we can just add these together, right? No, we can't, because if we did right now, it would be 6y. and that doesn't make a variable cancel. So you can't really solve that equation because it has two variables in it. So let's go back to the drawing board. So we don't want this. Oops. We don't want this. Let's get rid of that. And let's take a look. 4x plus 3y equals 2. Then we have 5x plus 3y equal negative 2. What if we were to subtract the second equation from the first? When we did that, be careful. You've got 4x. Always go back to this minus sign. You've got 4x minus 5x. That's negative x. And then you have 3y minus this 3y. Yes, that's nothing. Those go away. And then you have, be careful here. You have 2 minus negative 2. 2 minus negative 2 is 4. You have this negative x, so divide by negative 1, divide by negative 1, x equals 4. Sweet. Let's find out what y is. Let's take this idea for x and plug it into one of the original equations. Instead of x, we put what x is. X happens to be 4. That's a weird looking 4. Plus 3y equals 2. 16 is the same as here. And negative 16. Negative 16. How about, oopsies. Did you catch the mistake? I certainly did. Good thing I did. This here, this 4, that's right here, is positive. So when you divide it by a negative, it becomes negative. Be careful. So this one's negative. So this is negative. So this should be adding 16 to both sides. And you see that 18 is equal to 3y. Sorry about that. And if you divide the 3, y's truth must be 6. The value for x, negative 4. The value for y, 6. You could always plug this idea back into the original two equations and see if you get a true statement for each. Negative 4 times 5 is negative 20, and 18. Negative 20 and 18 gives you that negative 2. So that looks good. And then you can check it for this one if you want. So yay, this is fun. Let's keep going. Yet another system of equations. Now, you've got to be careful. The previous two equations were written in standard form, where x and y were lined up very nicely. Ax plus by, and everything was dandy. Sometimes, look, it's not given to you in standard form. It's best that you put it in standard form when you're using the method of elimination to solve systems of equations. Whew, so let's do that. You've got the first, which is already in standard form. Leave it as it is. And the second, in order to put it in standard form, you need to move this 3x to the other side. You can only do that by subtracting 3x from each side. Subtract 3x from each side. And on the left, you have negative 3x's, and those positive 4y's equals 14. Cool. What method can you use? Well, you can go straight to adding these equations because you see that the 4y and the negative 4y match up, so they will go away. As you add these, you'll have 5x equals negative 4 and 14 is 10. Oh, I'm as happy as a clam on Easter. X equals 2. Take that back up, put it into one of the original equations. The idea for x is 2, so it's 8 times 2 minus 4y equals negative 4. 16 minus 4y equals negative 4. And let's get all the numbers on the same side, negative 20. And you can see that negative 4 is being divided on each side, and y is worth 5. Sick. Went kind of fast, but this is the algebra part, and that should be easy to us by now. Result, the solution to this system is the 0.25. It works for both of these equations. It's where these things intersect. Cool. What I want you to do is to try any two of these. Any 3. Changed it. 3. Do 3 of these. And maybe do different types. Like this is a different type. than this. And these might be different types as well. So maybe try like 2, 4, and 5. Those are great. Yay, bye.